Okay, students, what we're going to do is we're going to do some of the problems from our book on 3.8. Let's take a look here on 3.8. I reviewed the lesson in that video. Let's look at a couple problems. So we'll need a marker. Hopefully you can see the board okay here. Let's start with number 1. All writers appreciate language. Okay, let's see. This is appreciate language. And of course, here's writers over here. All right, how many writers appreciate language? All of them do. So all writers appreciate language. Okay, hopefully that's coming across okay. Now, the next part says all poets are writers. Okay, is that true? All poets are writers? Yes. So here's poets. All poets are writers. What can we conclude about poets and people that appreciate language? Number 1, therefore, all poets appreciate language. Is that true? All poets appreciate language. So we could say we could see using the idea of the circles, the set theory, how we organize things. This must be true, and so that is a valid conclusion. Okay. That was number 1. Okay, let's look at number next, which was what? Was number 11. Okay, number 11. All professors are wise people. Okay, so let's see. Here we have the wise, like Yoda in Star Wars. All right, all professors are wise people, or so they are thought, right? Okay. So all professors are wise people. Some professors are actors. Some professors are actors. Okay, I think we have a lot of actors that think they're professors, okay, but some actors are professors. Now, could I do this? Could I put the circle like that? That does show that some actors are professors. But wait a minute. Could I also do this? Is this not showing also that some professors are actors and some actors are professors? Okay. Again, we're doing number 11. All professors are wise people. Got that. Number 2, some professors are actors. Okay, these are all of the possibilities here. And now the conclusion is, therefore, some wise people are actors. Some wise people are actors. Some wise people are actors. Here's some wise people. They're actors here. And is this showing that some wise people are actors here? It is also showing that too. So again, for number 11, I would say valid. Okay? Because for all of the possibilities, it is valid.
So, I mean, I would just sign it down here.
You sign it down there, that's right.
Okay. Now let's look at number 17. Okay, now we have 3 classes here. We have people who enjoy reading. We have people that enjoy watching TV. And we have people. So number 17, some people enjoy reading. All right, here are people. And this circle represents things that enjoy reading, okay? Actually, that would be people, right? Now again, is this showing some people enjoy reading? Yes. Number next. Some people enjoy TV. All right, some people enjoy TV. I could draw it like this. Some people enjoy TV. Let me try a different color. Well, what's another way to show that some people enjoy TV? Could I put it right here? Okay. Now, here's the conclusion. Therefore, some people who enjoy reading enjoy TV. Therefore, some people who enjoy reading, enjoy TV. Now, that is true right here, isn't it? Okay, that is very true. But remember, there cannot be a counterexample for you to make a valid argument. And we're reasoning deductively here. And in this case right here, aren't here some people who enjoy watching TV but don't enjoy reading as well? So because this is a counterexample, the argument is invalid. So keep that in mind. Okay, and then the last question here, number 31. 31. Let's see. We got some facts here. Let's take a second here. No ARB. What's something else we know? Some ARC. Some ARC. All CRD. All CRD. And then the last part is thus some DRB. Some DRB. Okay, that's kind of like my conclusion. Okay, that's what that little 3 dots mean. Okay. Well, let's just go right to it here. Okay. No ARB. Okay. Let's see. Here's A, and here's B. That would be disjunct, correct? Okay, no ARB. Some ARC. Okay, can I draw it this way? Can I draw it this way? Some ARB. Yeah, there's at least one A. I'm sorry. Some ARC. There's at least one A, that's a C. All right, now how about this? All CRD. All CRD. Could I draw, I'm going to use a different color, the D circle this way? Is this showing all CRD? All CRD. It is showing that. Now how about my conclusion? Therefore, some DRB. Some DRB. Well, I could have drew the circle, right? I could have drew it this way. That would be all DRB. No, that's not all DRB. I could have drawn it this way. Okay, would that show that some DRB? Some DRB? I could. But since there were a lot of different possibilities here, and I drew this counterexample, this shows no DRB because I can't say conclusively that it has to be some DRB. There's other possibilities. Because of the more than one possibility, I cannot conclude that it's valid. So if it's not valid, it is invalid. Okay? Now, there's a little stretch here, and it does use some of the ideas that we had before. It's another way of looking at logic, but this is how some people study the field of logic, and it helps them to a certain degree. Certainly we want to be good thinkers, and it requires all of our skills and all that we learned, especially those things that really helped us understand the meaning of the language and how to categorize and how to use inductive and deductive reasoning. So I hope this helps.